Today we're going to talk about the relative compression test on a 3.3 and a 3.8 engine. Those engines are typically used in our skid steers. We have a 299D back here that has a 3.8 in it. We have a 3.3 here that we've got removed. And we're going to take a look at a relative compression test. What a relative compression test is going to do is look at the engine mechanically and compare cylinders from one to another to determine if they're equal. We should be able to see if I've got a problem with the cylinder by doing a relative compression test, mechanical problem. The setup on this, if you look over here on the 3.3, is on this one we're actually going to the cam sensor. So we're teed into the cam sensor and going to look at the signal off of that. We're going to signal and ground. You can look right over in here, you can see we've got a current probe on the positive battery cable. So if I bring that over and look at it on the scope, it's going to look like this. And we'll take a look at the settings. Channel A is my cam sensor. You can see it's resting at 5 volts right now. My settings on it for channel A are 2 volts per division. I'm at 100 milliseconds per division for my time slice. And then I've got the current probe in channel B. I'm at 100 amps per division on it. And right now it's resting at 0 amps. So what we'll do is go ahead and crank it over. And when we get a good trace on there, we're gonna pause it and we'll talk about it for just a minute. Okay, so go ahead and crank it over. So this is a known good engine, right? And we're looking at a good trace here. So there is 4 identifiable events that are repeatable. So I start here, 2 downward slopes or traces, another, and then I come downward again and it repeats, right? So if I look at that with firing order, we're gonna talk about which one is which here in just a minute. My firing order is 1, 3, 4, 2. So if I look, the compression event is gonna happen after top dead center. So we're not looking at top dead center number 1, we're just looking at top dead center each one. My compression event should line up right in the middle of each one of those on this particular engine. So I have 4 identifiers and I have 4 compression events and they're relatively equal. So I would say this engine from a relative compression test is in good shape. As we've been talking, they've set up and pulled the number 1 glow plug out of this engine. So we'll go ahead and run it and look at that again, and then I'll show you how the firing order works. So we'll go to run, and when we get a good pattern, I'll hold it. Go ahead and crank it. So you can see now with my 4 indicators at the top, I've only got 3 compression events. So I've lost one. Well, we know number 1 is the one that we've lost because that's the glow plug we pulled out. We know our firing order is 1, 3, 4, 2, and that my current should happen on the compression event. So if I look at this closely, I'll see that this is actually cylinder number 2. The double identifier at the top is cylinder number 2. This would then in turn start my firing order. This would be number 1. This would be 3, this would be 4, and then I'm back to 2 again. I'm missing the one in number 1. So I've seen this quite a few times now. Why would they, the question is, why would they not put this at TDC? Why would they put it before TDC? The simple answer to that question logically would say, I want to know before number 1 happens, not when number 1 happens. So they typically are doing it the cylinder before, putting the unique identifier on the cylinder before. And this would be at the end of the firing order. Number 2 is right here. And then I'm looking for the compression event in number 1. It never happened. And then I get number 1, and then I get number 3, number 4, and then back to number 2. So now we look at one totally missing there, and you heard that, but now what we're gonna do is go ahead and run it, and what we've done is I've had him loosen a cylinder, but not tell me which one. So he put number 1 back in, and he's loosened a cylinder, loosened a glow plug, but not told me which one. So we'll go to run, and then we'll have our partner go ahead and crank it. Okay, so if I look at it here, I see number 1 is back in line. So remember, I'm after this one, so I see number 1 is back in line. Ooh, I see a little dip here. I see this one come up and this one come up. So I'm gonna guess that he loosened, and there's not much difference here, right? But all he's doing is loosen a glow plug a few turns. I can see here that number 3, if I follow my firing order, this is 1, number 3 is my problem. Am I right, Lucas? Good deal. So I can see a weakness there. Obviously, the worse it is, the more it's gonna come into play. So hope you learned something today. Hope maybe this can help you in doing your job. Relative compression test can be done on any engine. We don't have to know position. I just like to show that and how you can do it. This one's now verified, so we know position. If we do it on another engine, say we did a cylinder cutout test first and we had a weak cylinder number 5 on a 6-cylinder engine, but we don't know if it's mechanical or if it's the injector itself, I could just put the current probe on, crank it over, and if I've got one that's dropped below the rest, then I know right there that I do have a weak cylinder mechanically. If I want to verify which one, then I need to jump on the cam sensor and determine which one is number 1 and then go through firing order from there. Thanks for watching.